What if the oldest things in existence are not stars or galaxies, but questions? On clear nights, the sky can feel settled, ancient, perhaps, but orderly. Constellations keep their places. Light arrives from dependable directions. The universe, at least from a distance, appears to tell a coherent story. A beginning, an unfolding, a slow architecture of matter and time. We have built our science and much of our comfort around that sequence. And yet, at the edges of knowledge, the story begins to loosen. Astronomers and physicists have spent the last century listening for the first notes of creation. They have studied faint stars, relic particles, invisible fields, and patterns spread across billions of light years. Again and again, they have found something unsettling. Traces of structures, forces, and anomalies that seem to belong to moments earlier than expected, deeper than expected, perhaps even prior to the universe in the form we usually imagine. Not proof of impossible worlds, not a collapse of science, something more human than that. These discoveries reveal a truth both humbling and beautiful. The closer we move toward the beginning, the less the universe resembles a simple origin story. It becomes a place of echoes and thresholds, where light is not the oldest messenger, where time itself may blur, and where what we call a beginning may only be the first chapter we are capable of reading. This is not a journey into certainty, it is a journey into the oldest hints we have ever found, from stars that seem too ancient to exist to fields that may have shaped reality before matter had a name. Each one invites the same quiet question. When did the universe truly begin? And what, if anything, was waiting before that first dawn? Perhaps the deepest wonder is not that the cosmos keeps its secrets. It is that, for a brief moment, creatures made of dust and memory learned how to ask. How could a star seem older than the universe that contains it? It begins not with spectacle, but with a faint point of light in the constellation Libra. Nothing about it would catch the eye of a casual observer. No blazing color, no dramatic flare, just a quiet star, modest and remote, shining as though it belonged to the ordinary order of things. And yet this unassuming object, known as HD 140283, would come to unsettle one of the most basic assumptions in cosmology. Astronomers later gave it a more memorable name, Methuselah. The reason was simple. By the best measurements available, this ancient subgiant appeared to be extraordinarily old, so old that its estimated age brushed against, and for a time seemed to exceed, the accepted age of the universe itself. That result was not presented as a declaration that physics had failed. It was treated with care, recalculated, refined, debated. But even after adjustments and improved measurements, the star remained what it had always been, an object standing at the uncomfortable edge of the timeline. Its chemistry offered part of the explanation. Methuselah contains very little iron or other heavy elements, suggesting it formed from primordial material, from gas scarcely enriched by earlier generations of stars. In other words, it likely emerged near the dawn of cosmic history before the universe had fully learned complexity. It is less a bright ornament in the sky than a survivor from an austere age. And that is what makes it so moving. This is not merely a technical puzzle about margins of error or stellar models. It is a reminder that the universe does not always fit neatly into the narratives we compose for it. Our measurements are precise, but not perfect. Our theories are powerful, but still unfinished. Methuselah does not prove that time began differently than we think, but it does leave a small, persistent crack in our confidence. And through that crack comes something rare in science and in life, the chance to see certainty give way to deeper attention. Sometimes the oldest light is not a solution. It is a question that refuses to go dark. What could build a giant before the universe was ready for giants? Far beyond the reach of naked sight, beyond the familiar band of stars that once guided sailors home, there are beacons so distant their light began traveling toward us when the cosmos was still in its infancy. Among them are quasars, brilliant and violent sources powered by black holes of staggering mass. They do not glow gently. They blaze as if the young universe had already learned excess. That is the mystery. Some of these quasars appear in an era when the universe was less than 1 billion years old, and yet at their centers sit black holes weighing hundreds of millions, even billions of suns. By ordinary expectations, there should not have been enough time. Black holes can grow, certainly feeding on gas, merging with one another, gathering mass through the long patience of gravity. But these ancient quasars seem to have arrived early, like towering cities in a landscape that should still have been wilderness. Astronomers have proposed several possibilities. Perhaps the first black hole seeds were much larger than expected, born not from ordinary stars, but from the direct collapse of immense primordial gas clouds. Perhaps growth in the early universe was far more efficient than our standard models suggest. Or perhaps the first cosmic conditions were stranger, denser, and more accommodating to rapid structure than we have yet understood. None of these ideas is fantasy. Each is an attempt to follow evidence into territory where intuition fails. What makes these quasars so compelling is not just their size, but their timing. They force us to picture a young cosmos that was already capable of organizing matter into extremes. Before most galaxies had matured, before the universe had fully settled into recognizable forms, these gravitational engines were already burning at the centers of darkness. It changes the emotional scale of the early universe. We often imagine beginnings as simple, almost innocent, but the first chapters of reality may have been turbulent and ambitious, crowded with forces that move faster than our expectations. And so these distant quasars remain like lighthouses from a shore we do not fully know. They ask whether the universe began quietly at all, or whether from the start it carried within it the power to become immense before anyone thought it should. Can the universe carry a bruise from something beyond itself? The image is almost impossibly gentle, a map of ancient light spread across the sky like the fading warmth of a fire long gone out. This is the cosmic microwave background, the oldest light we can observe directly, released when the young universe cooled enough for radiation to travel freely. For scientists, it is more than a relic. It is a portrait of beginnings. And in that portrait, there is a blemish. In one region of the sky in the direction of Eridanus, the temperature dips lower than expected across an immense area. It is known simply as the cold spot. The name sounds modest, almost casual, but the anomaly itself has inspired years of debate. The early universe was not perfectly uniform, and small fluctuations are expected. They are, in fact, essential. From those slight irregularities, galaxies and clusters would eventually grow. But this region appears unusually large, unusually deep, unusually resistant to easy explanation. Some researchers have suggested that the effect could be linked to a vast underdense region of space, a cosmic void through which the ancient light traveled. Others have argued that it may still be an improbable, but not impossible statistical feature. And then there are the more speculative interpretations, offered carefully at the edges of theory. The possibility that this strange mark reflects physics beyond our current cosmological model, perhaps even an interaction with another domain of reality during the earliest moments of cosmic inflation. That last idea remains unproven and may ultimately be wrong. But it persists because the cold spot has a peculiar emotional power. It hints that even our clearest image of the early universe may contain a disturbance we do not yet know how to name. A scar, perhaps, or simply a misunderstanding. Either way, it reminds us that the cosmos is not obliged to look seamless just because we want a clean beginning. Sometimes the oldest light arrives with imperfections intact. Sometimes the map includes a silence where we expected music. And sometimes the most valuable thing an anomaly gives us is not an answer, but permission to imagine that reality may be wider than the frame through which we first learned to see it. What if some of the universe's oldest objects were born before the first star ever had a chance to die? Imagine a cosmos so young that there are no suns, no planets, no galaxies with spiraling arms, no familiar sky at all. Only a seething density, a pressure beyond ordinary language, where matter and energy have not yet settled into the forms we now recognize. In that nearly unthinkable beginning, some physicists believe gravity may have created its own first monuments. These are primordial black holes. Unlike the black holes we usually picture, which form when massive stars exhaust themselves and collapse, primordial black holes would require no stellar ancestry. They would emerge directly from the early universe itself, from pockets of density so extreme that space folded inward before light, chemistry, or structure had matured. They are, in that sense, not descendants of cosmic evolution. They are relics of the opening instant. The idea is both elegant and unsettling. If conditions in the first fraction of a second were uneven in just the right way, then gravity could have forged black holes across a startling range of sizes, from tiny objects with enormous mass to much larger bodies capable of persisting across cosmic history. Some may have evaporated long ago through quantum effects. Others, if they exist, could still be drifting unseen through the universe. What gives the concept its lasting power is not only its antiquity, but its invisibility. Primordial black holes have been proposed as one possible ingredient of dark matter, the hidden mass that shapes galaxies while refusing to shine. If even a fraction of that dark scaffolding comes from these ancient objects, then the universe we inhabit is being held together, at least in part, by remnants from an era before stars, before atoms, before anything a human mind would call a world. It is a haunting possibility. The oldest survivors may also be the hardest to find. And if gravity was already writing lasting structures into reality before the universe had fully taken form, then perhaps beginnings are never as blank as they appear. Perhaps every origin carries within it invisible inheritances, shaping the future long before the future knows how to look back. What existed before the first star turned darkness into light? There was a long interval at the beginning of cosmic history when the universe had already been born, but had not yet become luminous. No starlight crossed the void. No galaxies glittered in clusters. The great drama of the sky, as we know it, had not begun. There was only darkness, vast and patient, filled with immense clouds of hydrogen and helium drifting through expanding space. These were the first molecular reservoirs, the raw material of everything to come. It is easy to imagine creation as immediate, as though the universe burst into being fully expressive, already rich with form. But the evidence suggests something quieter and more austere. After the first particles formed and after the primordial chemistry of the early cosmos settled into its simplest elements, matter entered an age of waiting. Gravity began its slow work on these cold clouds, gathering and compressing them across millions of years. The future was present, but only as potential. That may be why these ancient clouds feel so evocative. They belong to a chapter of existence before visible structure, before any observer could have looked outward and seen a cosmos worth naming. And yet within them lay the ingredients of every later brilliance: the first stars, the first galaxies, the heavier elements forged in stellar hearts, the planets that would eventually circle quiet suns, the carbon that would become memory and breath. In those early clouds, the universe existed as promise. To study them is to encounter a form of beginnings that feels deeply familiar. Much of life unfolds the same way. Before expression comes silence. Before identity, accumulation. Before illumination, a long season in which the essential pieces gather in obscurity. So these primordial clouds are not only astronomical objects, they are reminders that emptiness is often misread. What appears vacant may simply be unfinished. What appears dark may already contain the architecture of light. And perhaps that is one of the oldest lessons the cosmos offers. The first visible spark is rarely the true beginning. It is only the moment when hidden preparation finally becomes impossible not to see. What if the oldest messengers in the universe have been passing through us all along? Long before the cosmos released its first visible light, before atoms settled into stable forms, before matter learned the elegance of stars and galaxies, there was another kind of witness already on its way. It moved almost without friction, almost without interruption, slipping through the newborn universe as though space itself could barely hold it. These were neutrinos, among the lightest and most elusive particles known to physics. And according to theory, they are everywhere still. Scientists call this relic population the cosmic neutrino background. If it exists as expected, it was set free roughly 1 second after the universe began its expansion. That may not sound ancient in human terms, but in cosmology it reaches astonishingly deep. It comes from an era when the universe was still a furnace of fundamental particles, too hot and dense for atoms, too young for light to travel freely in the way it does now. The cosmic microwave background gives us a later portrait, beautiful and invaluable, but the neutrino background would come from an even earlier page. What makes this so haunting is the intimacy of it. these primordial particles would not be confined to distant space, preserved only in remote corners of the cosmos. They would be here, passing through Earth, through stone, through oceans, through our bodies by the countless billions, carrying with them a memory of the first second, invisible, ancient, nearly impossible to detect directly. That near invisibility matters. It reminds us that the universe may be saturated with evidence we cannot easily touch. We tend to trust what shines, what leaves a visible trace, what can be framed in an image. But some of the oldest truths may travel in silence, embedded in particles so indifferent to ordinary matter that they cross the entire history of the cosmos almost unchanged. There is something deeply moving in that idea. The beginning was not lost. It is still here, flowing through the present. And perhaps knowledge itself often works this way. The most important signals are not always the loudest. Sometimes they are the ones that move through everything unnoticed, waiting for us to become subtle enough to feel them. What if the universe still carries the memory of a sound no ear could ever hear? Before there were stars to burn or planets to cool, the cosmos was not silent. It was filled with a dense, radiant plasma, a hot mixture of particles and light so tightly coupled that pressure moved through it in waves. In that early medium, the young universe rang with oscillations, vast pulses driven by a tension we know well in other forms, gravity drawing matter inward, radiation pushing it back out. These were not sounds in air. They were deeper than that. They are known today as baryon acoustic oscillations, and though the music itself faded long ago, its pattern remains. When the universe cooled enough for atoms to form and light to travel freely, those waves effectively froze into the structure of matter. Their imprint survived expansion, survived the birth of galaxies, survived billions of years of cosmic change. Even now, on the largest scales, galaxies are not scattered entirely at random. They still show a subtle preference for certain separations, like dancers whose positions were set by a rhythm they no longer remember hearing. There is something extraordinary in that. The broad architecture of the modern universe may have been shaped by pressure waves that moved through a formless, luminous sea before any recognizable object existed. Long before spiral galaxies turned in darkness, long before stars forged the elements of life, the cosmos had already begun drafting its geometry. This does not mean every detail was predetermined. The universe remains full of contingency, accident, and emergence. But it does mean that beneath what appears chaotic, there are ancient patterns, traces of an early order still influencing how matter gathers across unimaginable distances. In human life, we often discover the same thing too late. We imagine ourselves to be entirely products of the present, only to realize how much of our structure was shaped by forces long before conscious memory. Early conditions echo, first environments linger, old rhythms survive inside new forms. So it may be with the cosmos itself. The galaxies above us may be, in part, the crystallized aftermath of a song from the beginning, one whose notes have vanished, but whose cadence still holds the world together. What if the emptiest places in the universe that are not empty at all, but quietly threaded with an invisible inheritance? Between galaxies, beyond the bright assemblies of stars and the glowing dust that telescopes can easily celebrate, there are immense reaches of apparent nothingness. These intergalactic voids seem, at first glance, like the margins of creation, vast dark intervals separating the more dramatic structures of the cosmos. But modern observations suggest those spaces are not blank. They are crossed by magnetic fields so faint that they are almost ghost-like, and yet so widespread that they may belong to the universe's earliest design. This discovery changes the emotional texture of emptiness. Magnetic fields are familiar to us on local scales. Earth has one. So does the sun. Galaxies generate them, shape them, and respond to them. But finding signs of magnetism in the thin expanses between galaxy clusters raises a deeper question. Where did such fields come from? The usual astrophysical engines seem insufficient to explain structures stretched across such enormous distances. That has led many researchers to suspect a more ancient origin, perhaps tied to the first instance of cosmic evolution, when the universe was young enough for its fundamental forces and symmetries to behave in ways we still struggle to reconstruct. If that is true, then the cosmic web, the vast filamentary arrangement of matter spanning the observable universe, is not merely a network of gas and gravity. It may also be suspended within an older magnetic framework, a nearly invisible architecture established before the first stars appeared. These fields could have influenced how matter flowed, how galaxies formed, how energetic particles move through the dark between worlds. There is something quietly profound in that idea. The void is not a passive backdrop. It remembers. And perhaps that is one of the most difficult truths for any age to accept. Absence does not necessarily mean insignificance. The most delicate forces can shape the largest structures. The faintest traces can outlast the brightest flames. What looks like emptiness may, in time, reveal itself as the stage on which everything else was taught how to gather. What if the universe has been humming since its first breath, and only now have we begun to hear it? For centuries, space was imagined as silent. Beautiful, violent, immense, but silent. Then physics taught us to think differently. Space-time is not an empty backdrop. It can bend, ripple, tremble, and when massive objects move through it, especially black holes circling toward collision, they send waves across the fabric of reality itself. In recent years, astronomers have found evidence for something even stranger than isolated events. A background murmur of gravitational waves spread across the sky. Not a single note, but a chorus. A deep cosmic resonance produced by countless sources over vast ages, likely including the slow mergers of supermassive black holes in distant galaxies. It is less like hearing one bell and more like standing in a city at dusk, aware of a low collective sound made by everything at once. And yet the most intriguing possibility lies deeper in time. Some physicists suspect that hidden within this gravitational background may be an older component, one born in the earliest moments of cosmic history. If so, these waves could carry traces from an epoch far earlier than the release of light, perhaps even from the inflationary expansion that shaped the young universe in its first unimaginable fraction of a second. Unlike light, gravitational waves can travel through conditions that would have trapped or erased other signals. They may be among the only surviving messengers from reality's most inaccessible threshold. That possibility is difficult to overstate. It means the universe may preserve not only a visual memory of its past, but a physical vibration from its beginning, a structure of feeling, almost, written into space-time itself. There is something deeply human in this search. We are listening for origins not with ears, but with patience, mathematics, and instruments tuned to subtleties once thought forever unreachable. We are learning that the universe may remember itself in more ways than one. And if a primordial echo is truly there, woven into the gravitational hush around us, then existence did not simply begin and move on. It is still reverberating. What if the beginning of the universe was not an explosion but a field? When we speak casually about cosmic origins, we often picture a burst of light, a sudden eruption from nothing into everything. It is a vivid image and not entirely misleading. But modern cosmology invites a more subtle vision. Before stars, before atoms, before even the first stable structure of space as we now experience it, there may have been a condition governed by something stranger than matter or radiation, a field permeating reality itself. Physicists call the hypothetical agent behind this early transformation the inflaton field. The idea emerged as a way of explaining several deep puzzles at once. Why does the universe look so smooth on the largest scales? Why is its geometry so remarkably balanced? Why do regions now unimaginably far apart seem to share a common early history? Inflation offered an answer. In a tiny fraction of a second, the universe may have undergone a period of extreme expansion, stretching space so rapidly that minute quantum irregularities were drawn outward and became the seeds of all later structure. If that account is even approximately correct, then the inflaton field occupies a unique place in the human imagination. It would not merely be one ingredient inside the universe. It would be part of the condition from which the observable universe emerged. Matter, light, galaxies, and eventually life would all come later as consequences of a transition in that primordial field. And here the mystery deepens. What is such a field, really? Where did it come from? Did it begin with our cosmos, or does it belong to a wider framework from which universes can arise more than once? These questions remain unresolved, and they should remain unresolved honestly. The inflaton? is a theoretical idea, powerful but still incomplete, a map drawn toward a territory not yet directly seen. Still, its philosophical force is unmistakable. It asks us to imagine that what we call reality may rest upon something quieter and more fundamental than objects. Not a thing exactly, but a condition. Not a visible origin, but a generative backdrop. And if that is so, then perhaps existence did not start with a fire in the darkness. Perhaps it began with a change in the fabric beneath both fire and darkness alike. What if the universe did not begin once, but emerged from thresholds we are only now learning to imagine? By this point in the journey, the pattern is impossible to ignore. Again and again, when we press close to the first moments of cosmic history, the familiar picture begins to soften. Stars seem almost too old, black holes arrive too early. Invisible particles, magnetic fields, and gravitational ripples point toward epochs that light alone cannot reveal. The beginning, once imagined as a clean line, starts to resemble a shoreline in fog. This is where cosmology becomes more than measurement. It becomes interpretation. Some theories suggest that our observable universe may be only one local expression of a larger reality. Inflation, if it occurred, may not have been a singular event, but part of a broader process, generating regions of space with different histories and properties. Other models imagine a cosmos that expands and contracts in cycles, where what we call the Big Bang was not an absolute beginning, but a transition, a passage from one phase into another. Still others look to quantum gravity, where time itself may behave differently near the origin, dissolving the sharp boundary between before and after. None of these ideas has been crowned final. That matters. The honest frontier of science is not certainty dressed in grand language. It is disciplined wonder, guided by evidence and sharpened by doubt. Yet even without a definitive answer, something important has already changed. We no longer stand at the beginning thinking it is simple. We stand before it recognizing depth. And perhaps that recognition is its own kind of progress. Human beings often search for origins because we hope beginnings will explain everything that follows. But the universe may resist that desire. Its earliest moments may not offer a single clean key, only layers of emergence, hidden conditions, and unfinished questions. The first answer opens into another question, and that question into another horizon. So the mystery remains, not as failure, but as invitation. Perhaps the truest image of the beginning is not a door flung open once and for all, but a series of veils, each lifted by curiosity, each revealing not an ending to wonder, but a deeper form of it. Why do these ancient mysteries feel so personal, even when they unfold across billions of years and light years? Perhaps because every search for the beginning is also a search for ourselves. We study old stars, primordial particles, invisible fields, and buried patterns in cosmic radiation because they promise more than information. They promise orientation. They tell us where matter came from, how structure emerged, how darkness gave way to form. And beneath all of that is a quieter hope that by understanding the universe's earliest conditions, we might better understand the fragile present we inhabit. There is a profound tenderness in that effort. Human beings are brief, local creatures. Our lives are measured in decades. Our bodies are assembled from borrowed elements. Our certainties are narrow and often temporary. Yet we have learned to infer the history of reality from faint traces, a star's chemistry, a whisper in background radiation, a statistical pattern in the placement of galaxies. We are finite minds reaching toward an origin that may never be fully visible to us, and still we keep reaching. That persistence matters, because the deeper lesson of cosmology is not that the universe is cold or indifferent. Though at times it can seem so, it is that meaning does not depend on scale. A question asked sincerely in a small world can touch the edge of the oldest things. A species born late on an ordinary planet around an ordinary star can still become conscious of the vastness that produced it. That is not a minor fact. It may be one of the most remarkable events in cosmic history. So when we speak about beginnings, we are not only describing ancient processes. We are describing a relationship between the universe and the beings capable of wondering about it. We are acknowledging that knowledge is itself part of the story, one of the ways the cosmos becomes aware of its own depth. And that may be the hidden thread running through every mystery we have followed. The beginning is not only behind us, In another sense, it is happening now. Each time awareness rises from matter and dares to ask where the light first came from. So where does all of this leave us? Not with a final answer, not with a neat diagram of creation, every mystery labeled and resolved. It leaves us somewhere more honest and perhaps more meaningful. At the threshold between knowledge and wonder, where the universe becomes stranger, the more carefully we learn to see it. We began with the possibility that some things seem older than the cosmos itself, or at least older than our simplest account of it. We passed through black holes that grew too quickly, ancient light marked by anomalies, invisible particles from the first second, gravitational echoes that may outlast every star, and a primordial field that might underlie the very existence of space and time. Each example carried its own uncertainty. Each belonged not to fantasy, but to the serious and unfinished labor of trying to understand reality. And together they reveal something quietly transformative. The beginning may not be a single moment sitting cleanly behind us. It may be layered, distributed, partially hidden by the limits of our instruments and the structure of time itself. What we call an origin may instead be a frontier, one that recedes as our questions grow more precise. That is not a weakness in science. It is one of its deepest strengths, the willingness to let the universe remain larger than our current explanations. There is comfort in that if we allow it. Because our lives are shaped by beginnings we do not fully remember. Personal, historical, biological. We emerge from conditions already in motion. We inherit patterns, materials, and stories older than ourselves. In that sense, the cosmos is not foreign to us at all. Its layered origins echo through our own. Perhaps that is the final insight. We do not stand apart from the mystery, looking in. We are inside it, made by ancient processes, animated by temporary consciousness, asking questions that reach farther than our brief lives should logically permit. And maybe that is enough, not to possess the beginning, but to meet it with humility, not to conquer mystery, but to be enlarged by it, to look into the dark, listen for the oldest echoes, and understand that the search itself is one of the most human things the universe has ever produced.